In this video, we're going to look at proving trig identities, and we've got a few examples to work through. So we're going to skip out this few bit of notes and jump straight to the examples. The first one says prove that sec theta cosec theta is identically equal to, this sign means identically equal to, tan theta plus cot theta. So in these questions, what you must do is work with one side and one side only. So I'm going to be saying either LHS equals, which stands for the left hand side equals, or I'll be saying RHS equals. And I'm going to be working through until I get that my right hand side is equal to my left hand side. Now you work with one side only, and quite often there will be one side which is easier to work with. So I always pick the side that it looks like it's easier to get started, or there's more to do. So in this one, I'm going to look at this, and I'm going to look at my right hand side. The reason I'm looking at my right hand side, if you look at this right hand side, it's got two separate terms. It's got a tan term, and it's got a cot term. So I'm going to look at my right hand side. Okay, when you're doing it, I always say keep one eye on the prize, so keep one eye where you're going to. So I'm trying to get to sec theta cosec. So sec involves cos, it's 1 over cos. Cosec involves sine, because it's 1 over sine. So I'd be thinking to change my tan theta and my cot theta to be in terms of sine and cos. So if you think back to our first identities for trig, it said that tan is equal to sine theta over cos theta, whereas cot was the reciprocal of tan, so it's going to be cos theta over sine theta. Now again, keep one eye on where you're trying to get to. We're trying to get to here sec theta cos theta, sec theta cosec theta, sorry. That's all like one term. At the minute we've got two separate terms being added. So what I'm going to do is try and make that one term, and I'm going to do that by taking a common denominator. So adding the fractions, my common denominator, just multiply the denominator. So it's going to be cos theta, sine theta, and this bottom denominator cos theta got multiplied by sine to give you cos times sine. So we have to multiply the top line by sine as well. So sine times sine is going to give you sine squared. So we're going to have a sine squared in here. Likewise, this sine got multiplied by cos to give you cos theta sine theta. So our top line also gets multiplied by cos, which will give you cos squared theta. Now, what we have here, if we go on down, I don't know why that's highlighted, made it worse. If we go on down, we know that this top line, sine squared plus cos squared, sine squared plus cos squared equals 1. So we can just rewrite that as 1 over cos theta sine theta. And again, have a look where you're trying to get to. We're not quite there. I'm just going to write that as 1 over cos theta times 1 over sine theta, which is equal to, and just write this line in, that's sec theta times cosec theta, and your last thing to say, which is equal to the left hand side, sorry. Give it a wee tick, you know that is correct. So it's a great question to get in an exam, because you're told what the answer is. As long as you follow the steps properly, you can see I've rearranged my right hand side until it becomes my left hand side, so I know I'm going to be getting full marks. Okay, in this next example, I'm going to look at this one and think, well, I have to prove that 1 over 1 plus cos alpha plus 1 over 1 minus cos alpha is equal to 2 cosec squared alpha. Not a clue how I'm going to do this one, but I'm going to think, is it going to be easier for me to work with the left hand side or the right hand side? And definitely the left hand side I can do more with. So what I'm going to do is say my LHS, my left hand side, equals, and all I'm going to do is take a common denominator here. So it's going to be 1 plus cos alpha upon 1 plus cos alpha, and my top line is going to be, so this first term needed to be multiplied by 1 minus cos alpha, so you multiply it in. The second term also gets multiplied by 1 plus cos alpha, and then we're just going to multiply it all out and see what we get. Okay, multiplying out this bottom line, you should see, if you multiply out this bottom line, this is the difference of two squares, so what you get on the bottom line is 1 minus cos squared alpha. And on our top line, what you're going to get is 1 minus cos alpha plus 1 plus cos alpha, so the cos alphas cancel out, leaving you just 2. Okay, how are we going to get to our answer here? What we know, remember we know that sine squared alpha plus cos squared alpha equals 1. That means if you have sine squared alpha is going to be equal to 1 minus cos squared alpha. And this is what we have on our denominator on our bottom line. So on the bottom line, you really have 2 over sine squared alpha, which is equal to 2 over 2 over sine squared alpha is 2 cosec squared alpha, which equals your right hand side in this case. And again, you know you've got full marks. Brilliant. Okay, very ugly looking proof here, but I would think on this one I would work with my right hand side. So we'll just get started, and if it gets really complicated you can change and go to your left hand side, so don't be panicking too much. Right, the left hand side we have got, and I'm going to change these both. I'm going to write them as 1 over, and that's going to be cos to the power 4y minus 1 over sine to the power 4y. So then we're going to take a common denominator, and I'm going to write it as cos to the power 4y sine to the power 4y as my denominator, and the top one needs to be multiplied by sine to the power 4y. Sorry, the left one needs to be multiplied by sine to the power 4, the right one needs to be multiplied by cos to the power 4. So that's what we've got so far. So, okay, the bottom line, I'm not going to see it if I leave it this way. This is the same as this bottom line. I'm just going to rewrite this back the way they had it, which was sine to the power 4, cos to the power 4. So I've done nothing mathematical there at all. All I've done is change the order that they were written. That's it. And my top line, now this is tricky to see. My top line is the difference of two squares. This is sine to the power 4y is the same as sine squared y. So that goes in each bracket. Sine squared y squared, I should say. And cos to the power 4 is cos squared squared. So that's cos squared y. And then plus cos squared y. And we'll go on up here to finish this off. Okay, we'll write down our denominator. It's fine. Sine to the power 4y, cos to the power 4y. And this bracket is what we want. We wanted this bracket sine squared y plus cos squared y. And what is sine squared plus cos squared? Sine squared plus cos squared is equal to 1. So we're left with sine squared y plus cos squared y all over sine to the power 4y cos to the power 4y, which is equal to our left hand side. And again, you know you're right. You haven't broken any rules. You've got your full marks. Okay, there's two ways. You could really use either side for this one. If you were using the left hand side, you would rewrite everything in terms of sine and cos, and then just go from there, and you can get there. I just want to show you using the right hand side for the purpose of the video, just because it's a bit of a strange method, but there's nothing wrong with it. So in your notes you'll have two methods, but I'm just going to show the right hand side method for the video. Okay, on my right hand side I've got 1 plus cos x over 1 minus cos x. Now if you look at this, that's my right hand side. My left hand side has got no denominator, so the denominator overall is 1. So in one like this, what you can do is multiply top and bottom by 1 plus cos x. And it's a strange method, but I liken this method to rationalizing the denominator in surds. If you had like 1 plus, sorry, we'll not change that. We'll have, eraser's not working here. If we had just 1 over 1 minus root 2, to rationalize you would multiply top and bottom by 1 plus root 2. So remember, when you're doing this, all you're doing, 1 plus root 2 divided by 1 plus root 2 is just 1. So doing this just changes how the thing looks, but it doesn't change its value. And that's exactly what we're doing here. We're multiplying top and bottom by 1 plus cos theta. So this term here is effectively 1. So it doesn't change how this thing, it doesn't change the value of this thing, but it does change how it looks. So we're just going to go ahead and see what happens. So multiply out your bottom line. You're going to have 1 minus cos x upon 1 plus cos x, and your top line is going to be 1 plus cos x. 1 plus cos x, I'm just going to write 1 plus cos x all squared. Now my top line was 1 plus cos x all squared. Now if you have a look at what happens, and I think I will just write that out Oh, sorry. Yep, if we have that, sorry, what would happen here is that is bottom line is going to be just become, oh, this is frozen. Bottom line is just going to become 1 minus cos squared x. That's just by the difference of two squares. And your top line, we're going to leave it still as 1 plus cos x squared. And then we'll tidy up. That's just going to be 1 plus cos x all squared. And my bottom line, 1 minus cos squared. I think we saw a couple examples ago that was just the same as sine squared. And then we'll go over here to finish that off. And really what we have, both things are being squared. So really it is just 1 plus cos x on my top line, sine x on my bottom line. And that's all being squared. And that really is the same as 1 over sine x plus cos x over sine x. That's all being squared. And what is 1 over sine x? It is cosec x. And cos over sine is cot x. And that's all being squared. And it's written the other way around, but it's exactly the same. That's my left-hand side. So I've got my full marks. Okay, last one here, and I'm going to work with my left-hand side. So my LHS is going to be equal to the square root of, and similar to the last example, I've got 1 minus cos x over 1 plus cos x, and I'm going to multiply top and bottom by 1 minus cos x and see what we get. So this is all within the square root sign. So if I do that, top line is 1 minus cos x. That's going to be all squared, and my bottom line is going to be 1 minus cos squared x. And again, that's the square root of 1 minus cos x, all squared, all over sine squared x. And then if you just square root the top, you'll get 1 minus cos x. Square root the bottom, you'll get sine x. And that is the same then as 1 over sine, which is just going to be cosec x, and then cos over sine, which is cot. So cosec x minus cot x, which is equal to your right hand side, so you know you're correct. Okay folks, you're now ready to do some questions. I'll just write. Okay, so the questions you're able to do: topic 5, exercise 3, question 2, and exercise 6 as extras if needed.